Hey everyone, welcome back to another video. So there's been a couple of questions on how to create a Niagara system in the new template, specifically for a pointer on the controller. So it could be left or right. So in this case, we're going to go through and show you how you can create a VR pointer from one of the controllers, or both if you wanted that. And yeah, so let's get started. So the first thing we're going to do is go to View Options and then Show Plugin Content. And if we scroll down on the left here, so I'll make this bigger just so you guys can see it. We're going to search for OpenXR content, devices, and then in here you'll see that we have all of our VR controllers. So it's going to depend on what platform you're using for this. So what we're going to do is, because I'm using the Valve Index for this example, it's going to work with any other headset. What you do is we're going to open up the controller and we need to decide which hand we want the pointer on. So rather than doing both, because it's the exact same process, you'll be able to figure it out, I'm going to use the right hand, so the right controller. I'm going to open the menu and I'm going to be able to point and click on other stuff. And to do that, we're going to start by adding a socket to the controller. So see here, I've got the controllers. I'm going to open up the right Valve Index controller. Now if we zoom right in, we can see our right mesh and we can double check that's the right one. And what we're going to do here is we're actually going to use a socket. So we're going to create a socket and we're going to call this pointer. And I'm going to move this forward. I'm not too sure of the orientation of this socket at the minute, so we'll probably actually come back into this later on and rotate it around. So what I'm going to do is I'm just going to dock this window at the top. That way we can come back and then rotate this if needed. So that's it for our controller. We need to make sure we remember that we called it pointer. And what you can actually do is you can right click and then copy that. So we'll use it again in a minute. Now what we need to do is actually create a new folder. Actually, I think we've already got a folder in here. VR template, VFX, exactly. So in here, we're going to go to VR template, VFX, right click. We want to FX Niagara system. And we're going to actually, and in here, what we're going to do is we're going to select new system from selected emitters. And then we're going to choose dynamic beam. Want to hit the plus. So we add that emitter in here. You can go through and add a couple of other ones, but we specifically want the dynamic beam for this example. So we're going to hit finish. Let's call this ns underscore pointer. And we're going to open this up. Now, if this is your first time working with Niagara systems, don't be too worried because it's not really that complicated, especially what we're going to do here. So you should be able to keep up pretty fine. I'm going to pause this timeline just so it's not continuously playing. And the first thing we're going to do is select our dynamic beam. And you'll see we get an absolute load of settings and information that we can go through. And essentially, this is what we're going to change to control our beam and give us access to it. So once we finish this, you can actually go around and play with all of these settings to see how it will affect your beam. But first thing we're going to do is set our loop duration to 0.1, 0.01. We're then going to set our spawn count to 2 and our lifetime here to 0.2. And then the next thing we're going to do is find our beam width. And this essentially controls the shape of our beam that comes out of our controller. So what we want to do is actually straighten this out a little bit. I normally do this by deleting the top pin and then rotating this one around and this one. And especially if you want it to be completely straight beam, you can then just move this up. So 0.2, or we'll go a little bit higher. So it'll be quite a thick beam. And you see we can see it actually changing here. So one's going to be really thick, and then 0.5 be half, and then key data, I'll be fine leaving it at 0. But what you can do is you can actually zoom out to find our other pin, or we'll add a key, just so we can move it around. And you'll see that actually modifying this changes the way our beam moves. So say we make it wider on one end and pointy at the other. And that's what we're going to do here. We're actually going to set this one to 0. So it goes down towards a little point. You could have it so we've got another one in the middle. If we just add another key. It's probably too short to be able to see, but it does curve up. I'm going to hit save on that one. And here you can actually change the color of your beam if you wanted to. So you can have it whatever color you want. And I'm going to show you how to actually add a parameter in here in a second. So you'd actually be able to control this yourself through the blueprint. Just double checking all of the particles down below. We don't need to touch any of those. But what we do need to do is go back up to the top. And you'll see here we have a setting called beam end. And if we change the length of this, this is what controls how long our beam is. And this is where we're going to add a custom parameter. So I'm going to set that back to 200 default. And on the left here, you have a tab called parameters, user exposed. We're going to hit plus, and we're going to search for a vector 3, which in this case is just a vector. And we're going to call this beam end. And what we can do now is we can actually just drag this onto our beam end, and it'll automatically update our information. There we go. And now if we want to change this setting, because usually it's technically 000 because it's a default variable. So if we check NS pointer, you'll see on the top right here, we actually have controls to set the default value. So default value is going to be 200. And now we can hit save and compile. And we're going to close this down. And what I want to do now is actually jump over to our blueprint for our VR pawn. So now we get into the fun part. So we're going to find our VR pawn, and we're going to actually find some free space to work in. Or at least this section here does. So we've got input action menu left, input action menu right. So once we press these buttons, we spawn our menu. So what we're going to do is we're actually going to use these to spawn our pointer. So if the left menu is toggled, we would spawn the right controller, or the pointer on the right controller. If the right menu was toggled, we'd spawn the left controller. So you can see how it will be switched around. So the first thing we'll do is go underneath and we'll do a custom event. And we're going to call this spawn pointer particle. And now what we want to do is actually use this pin to spawn system attached. So right here under Niagara, we're going to drop this in. And then we're going to right click on the return value and we're going to promote to a variable. So we're going to call this pointer spawn, because what we're going to do is when we press the button, we're going to spawn the pointer. And when we release the button, we're going to destroy it. That way it's not continuously firing on screen and you don't need it. Now what we need to do is set up our spawn system. So see, we've got system template. If we have a look through here, we'll have all of our Niagara systems. And what we're looking for is our NS pointer. So that's the one we just created. And if you remember, our socket is called pointer. And this is what we're going to use to attach the particle effect to. So what we're going to do is we're going to get our hand, we're going to get the socket and attach this to it directly. Because of that, we don't actually need to set our location and rotation because it's already stored. But what we can do is location type, we're going to set this to snap to target, keep world scale. And now we can get our controller. So we're going to get our motion controller right. We're going to drag that in. And then we'll search get mesh. So get custom display mesh. Or in this case, we don't actually need that. We should just be able to attach the component. We might have to come back in and see if this works properly, but we'll go from there. So now we're going to go down below. We'll do another custom event. And we're going to call this destroy particle or destroy pointer. And then we're going to check to see if our right pointer is valid. So get is valid with the question mark. And what this is going to say is essentially if this variable has information in it, then it needs to be destroyed once we release the controller. If we did this and not, it might bug out and then you'll get a load of errors, but this just fixes. And then we can drag off the pointer spawned and search destroy component. Plug that into is valid. And before we move on to everything else, we might as well test this out. What we can do is we can go to our menu toggle left and drag off there and spawn pointer particle. We could have called that spawn pointer particle right, which would have been easier, and then destroy right. Actually, that could have been the same. That would just be destroy pointer, and then you could add the second pointer spawned as another variable in there. So have a sequence. So we'll drag this over so it's lined up, and then destroy pointer. Keep this down here. So if we jump in and we test it now, we should be able to see our pointer here. So it appears, but as soon as I let go of the button, it stops. So that's what we're going to have to fix now. And that's going to be because I've got the destroy on release. What we need to do is do it so once we press it again, we flip-flop down, and then we destroy it. Let's do toggle menu, and then we'll do flip-flop here. So the first time, it spawns a particle, and then the second time, we destroy the particle. So we test it again. See, we've got our pointer, and it's already lined up, which means we don't have to do anything with our sockets, which is excellent. And now what we're going to do is we're going to actually go through and we're going to program it so the beam changes its length and its scale based on how close something is to you. So at the minute, it's really far away. That's because the default value is 200 units. And to do this, we're actually going to use our particle, or pointer. So our widget interaction right, which is the one that's attached to our right controller. You can see here we have an interaction distance of 500. So that's quite a lot bigger than what we default have at 200. So we're actually going to use this value to control how long our beam is. And it's actually super easy to do. First thing we're going to do is get a custom event. And we're going to call this update particle length. Try and move that. We're going to get a reference to our pointer spawned, and we're going to check to see if that is valid again, exactly the same as what we've got here. So get pointer is valid. If it is, we're going to do a branch. And we'll set up this condition in a minute. And this condition is actually going to be used by is the hit result hitting a widget. So if it's hitting a widget, we're going to shrink our beam to match the distance between us and that widget. If not, when we point away from it, we're going to go to a default length, which just looks a little bit nicer and it feels a little bit more solid as a final result. And now we can drag off our pointer spawned and set Niagara variable. And we want to set a vector 3. So set Niagara vector 3. And if you remember, a vector 3 is what our beam end values are. So if it's true, we're going to have beam end update to a current value. And we're going to duplicate this down. So we got 2, 1 from the false. And our target is going to be our spawn pointer. And what this does is it allows us to set these values in our blueprint rather than directly in our Niagara system. It's essentially doing the same thing, it's just communicating between both. But what we need to do is split our pins because we need access to the X value. And now what we want to do is get a reference to our right interaction. So our widget interaction right, I'm going to drag this in. We'll need some room for this. We're going to search get last hit result. We could split this pin, but it's easier to just do a break results. Keeps things organized. So we'll move this over. And you'll see here now that we can actually get access to all the information about what our actual interaction pointer is hitting or our widget interaction is actually hitting. So we're going to get our distance and we're going to set our X value for the first beam. So basically once this interaction or the widget interaction collides with a widget, it's going to update the position to be smaller. We then want to get our widget interaction, do is over hit test visible widget, which is a bit of a long one. And if we move this up like so, we'll plug this into our branch. So this is basically saying, are we hitting a widget yes, then we're going to make the beam match the length of our widget interaction. If not, we're just going to default back to our shorter length, which would be the default line of our widget interaction right. And to do that, you can just drag off the widget interaction and do search distance, so get interaction distance, and plug that into the X value. So the thing is, if you don't want it to be really long, you can actually change this value. So I'll show you like this, and then we'll change this to be a little bit nicer. So if we now have to fire this update particle length, and to do that, we're actually going to use event tick. So we can bring this down. We can search for our event tick, which I don't actually think the new template has one. Excellent. So just to keep with that, what we will do is we'll keep this organized and actually pretty good for performance. So we won't use tick. And what we'll do is we'll actually set this up to be a timer rather than an event tick. So we keep with the workflow that's already in the template. So we'll drag off our spawn pointer particle and then search timer, set timer by event. And we're going to make this looping, and we'll do 0.1, which will be the same length as a event tick. And we'll make sure it's looping. And then what we can do is so we could actually drag this red pin all the way down to here, but it's just going to get really cluttered. So rather than doing that, we're just going to drag off event, and we're going to do event dispatches, and then create event. And then we're going to scroll down and search for update particle length, which is the name of our function, or at least in this case, our custom event. And all that does is basically says, once this is fired, fire this node, essentially. So hit compile and save, and then we jump in and test it. We'll see that update. But before I do, so I don't forget, I actually want to on destroy, clear the timer. So clear, and then just for good practice, we're going to actually stop this timer, or at least this one firing, by doing clear timer by function name. And then we just add in update particle. So rather than right now, we'll be super lazy and we'll just copy and paste this like so. And now, if I remove that print string, we should be good to go. So we can do compile and save, hit play. Now if we jump in, we can open up our menu. See our pointer is absolutely huge. Doesn't interact with anything else. But if we point at our widget, it actually shrinks to match the size, and we can see where we're actually pointing at, which is super cool. So we're going to do some more stuff to change the scale of this. So rather than having it change the interaction distance back to the length of the interaction right, I'm actually going to disconnect this. We'll keep that there just in case you want to use it again. And we'll set this to, we'll try 30. And save. And what I want to do is actually go back to the pointer VFX. So the actual the particle itself. And I want to change the width of this beam because it's pretty thick. So I'm going to set to 0.2. We'll try that. It can be really small. And then we'll just delete that middle pin actually. So it has a nice loop. So we hit compile and save again. Jump right in. Our beam should actually be smaller or shorter when we're not pointing. So we can see it there. I would say it goes along to begin with and then shrinks back down. So we'll have to check that. But now it actually increases in length based on whereabouts you're pointing. So it's not too bad now, which looks much better than what we had by default. It's super cool. So now we just need to figure out why our beam goes really long and then short. So what's happening is we set our default pointer scale. So we go back to our pointer, and here we have it set at a length. So our user parameter, this one, at a length of 200. So by default, it spawns. It goes straight to 200, and it doesn't update until we actually, like, after a couple of seconds, like half a second, which is why we see it bounce back. So our default value is going to be 30. So let's just change this to 30. So now if we actually save and compile, and while I'm here, I know it's annoying, but I'm going to actually change the length of this to 0.1 and then make it go to a point. So now if we press play, go in and press the button, we go to our pointer, we can point at stuff, interact with it all, and then when we close it, it comes back, and then we only have our pointer particle when we open our menu. So as a recap, we created a socket on our controller, which we can then attach our pointer to, which we're doing right here. We created our particle with Niagara. This does work on the Oculus Quest. I've tested it, so don't worry too much about that. We then destroy our particle once our menu is closed, and then we update the length based on our widget interaction information. So that's it for this video. I really hope this helped. If it did, let me know in the comments below. And if there's anything else you want to see regarding Niagara or particles, then it would be awesome to hear what you want, and then I can look into it. Don't forget to comment your code, as I haven't done here, but this video is getting on, so I'll let you go. A big shout out to my Patreons for making this video possible, and everybody over in the Discord who asked about this. And yeah, until next time, stay safe, and I'll see you then.